Hello students, welcome to chemistry class. Today we're going to be talking on the topic titled electrochemistry. Electrochemistry. So my name is Oyelami Jane Italy, and our objectives are into various parts because of the volume of the class, of the topic rather. So today we are going to be treating all these on the part one. So at the end of this class, you should be able to explain the scope of electrochemistry. You should be able to understand electrical conduction in substances, as well as what? Know more about electrolysis. So scope of electrochemistry now. Electrochemistry deals with one, interrelationship between electricity and chemistry. So therefore, you have to know that chemical reactions are made to occur by passage of electricity. Also, electricity is produced by means of chemical reaction. The second one is that the ability of the substances to allow the passage of or transfer of electricity through them. So electrical conduction in substances. This is the passage of electricity through a substance. So underneath this, we're going to be looking at some terms. Conductor, as we all know, they are substances or elements that allow what? Passage of electricity. And an electrolyte is a compound if when in molten form means in liquid form, or when it's dissolved in water, that's in aqueous solution, is what can conduct electricity. While this is opposite of conductor, this one will not allow electricity to pass through them. Likewise, non-electrolytes will what? Are compounds that when in molten form or aqueous solution will not conduct electricity. So you have to know that it's like word and opposite for conductors and electrolytes. So based on nature of carriers of electricity present in a substance, we're going to be looking at various ones. The first one on my list is electronic conduction. Electronic conduction occurs in substances having free mobile electron in their lattices. That is, electrons are carriers of electricity. So all metals, virtually all metals, and graphite, which is an allotropy, is an allotropy of carbon. You know, it behaves like a metal anyway. It has free mobile electron in its lattice. So those are the ones that are really, they are good carriers of what? Electricity. Then that will lead us to Ohm's law. Ohm's law states that the potential difference is directly proportional to the what? To the resistance of the current that the metallic conductor carries. So we have it as V equals to I R, where our R is proportionality constant in ohms, that's the unit. Okay, so a typical electrolytic cell, the terminal of an electrolytic cell are called electrode. Okay, you call the terminal of an electrolytic cell an electrode. They carry electric current in and out of the cell. And there are two electrodes in a cell. The first one is anode. Anode is called the positively charged electrode. It takes electric current from power source to the electrolyte. Hence, they attract what? Negative ion, like pole attract, like pole repel while unlike pole attract. So here it carries what? It carries electricity from this power source. That's the work of anode. From this power source into the electrolyte. This is the electrolyte. If you look closely, you see positively charged ion are attracted towards what? The cathode, while negatively charged ion are attracted towards what? Anode, because unlike pole attracts. Okay, cathode is the electrode with negative charge. It carries electric current from electrolyte back into the power source, hence attract positive ion. So you can just look at generally this is what happens there. So electrolytic process involves three steps. The first step on my list is ionization of electrolyte and water. That's if the compound is what is diluted with water, you call it aqueous solution. That's electrolyte and water. If not, you call it electrolyte alone in molten form. For example, we have copper sulfate. Copper sulfate is an aqueous compound because is dissolved in water. So here you have to write two equations for it. You have for copper sulfate giving you copper 2 plus and SO for 2 minus. Then for the water, water ionizes too. So for water you have something like H plus and OH minus. Pardon me there. Should be minus. So Pb in the second option where you have only electrolyte, you have something like this where you have lead-2 bromide. Okay, it ionizes to give you this. So electrolytic cell, this is how it generally looks like. Okay, so just have a look and enjoy it. So second one is migration of ion to the electrode. How does ion being migrated to the electrode? It occurs when the switch is on. As soon as the battery is put in place, you have definitely the compound is in molten form. That means they are dissociated. Okay, we have positive and negative. They form ion in that solution. So as soon as that happens, if you put on the battery, or the battery is being connected to it, the positive charge ion migrates to the cathode and the negative charge ion migrates to the anode. So look at what I wrote here. For copper sulfate, these two supposed to be the product. But when you talk about water, they're supposed to be the product. So this will now migrate. So copper 2 plus will migrate to what? Okay, copper 2 plus will migrate to cathode. That means it will be deposited at cathode, while sulfate ion will migrate to the anode, being positive electrode, and it will be deposited there. So that's how it looks like. So you can try it for water. Which one do you think will migrate to anode and which one will migrate to anode? So this electrolytic cell part, just to show you how it is on a normal day. This is how it is. In anode, oxidation takes place, and at cathode, reduction takes place. So this is the electrolyte, and this is what happens there. Okay, because this one is negatively charged, this one is positively charged. So that's how it looks like. So discharge, the last one is discharge of ion at the electrode. It involves a gain of electron, which is called reduction at the cathode, and a loss of what? Electron, which is called oxidation at the anode. This is redox reaction because both of them are taking place at the same time, simultaneously. So Re is from what? Reduction, Y what? OX is from oxidation, redox reaction. Okay, so memory tip, how to understand better. CRAO, that's the acronym I use right now. Cathode means reduction, while anode means what? Oxidation. So here, in example, in lead bromide, this is what happens. Okay, so lead will migrate, lead-2 plus will migrate to the cathode, and it will be reduced to lead. Okay, I want you to write that equation on your own. That's why I didn't finish it up. It will be reduced to lead, neutral lead. Why this one, which is bromide ion, will migrate to where? It will migrate to anode, which is the positively charged electrode, and it will what? So I want you to write it. So this is how to know when the discharge, the preference in discharge in solution. Okay, this ease of discharge. So for instance now, silver will easily be discharged, be preferred to be discharged than potassium or than lead or than, it depends on the compound, the molten state. So same thing here too, when you have sodium chloride and you have water, the OH minus will be preferable to Cl minus. That's ease of discharge, because for chlorine to be used, there's extra energy that is attached to that. So it prefers using the one below. Okay, that's how it works, electrochemical series. So at the cathode, I've even written it for you. So this is what happened, and at the anode, this is what happened, oxidation. So for cases where two different ions having the same charge type migrate to electrode, one of the ion is selected for preferential discharge. That's what I just explained to you. So concentration of electrolytes. Concentration too matters. How concentrated the substance is will determine which one it will prefer to discharge. So look at them and have a look. Just pause the video and read through. It's quite explanatory. Same thing with nature of electrode. It depends on the nature of electrode being used that will determine what will be discharged. Okay, so this is it. When you have platinum cathode, you have H plus being lower in the reactivity series than sodium ion. So which one do you think it will prefer? Of course, hydrogen ion. So look through and just practice some questions on your own. That's nature of electrode. So in a nutshell, I put them together here. The three things you have to put into consideration why talking about electrolysis. Depends on nature of the electrode. It depends on the maybe it's inert electrode you are using, just like platinum, nickel, and what have you, or the active electrode that you are using, which can participate in the reaction, just like you have in copper and silver. So don't limit yourself to what we talk about in class. Try to do more of reading. It's easier for you to grab more when someone explains a bit of it to you. So you have to read on your own, do some research, know more about all the things we've discussed today, and make sure you enjoy your day and be good. Bye.